AI is everywhere. So wherever you look right now in the tech world, you probably see or hear about AI. I invited the DevRel, Taylor, the DevRel at Supabase to talk about AI features in Supabase. Hello, Taylor.
I'm so excited to be here today.
Tell us what is Supabase and what do you have for us in terms of AI features in Supabase?
Supabase is basically a Postgres developer platform.
Welcome to another episode of Flutter Original Show. So this time I have a different topic for you. So AI is everywhere. So wherever you look right now in the tech world, you probably see or hear about AI. And you know that I'm also a big fan of Supabase. We already had a Supabase in my channel. And again, I invited the DevRel, Taylor, the DevRel at Supabase to talk about AI features in Supabase. So if you don't know what is Supabase or you're coming to this channel for the first time, don't worry about it. I'm just going to welcome Taylor right now, and he's going to introduce himself. Hello, Taylor. And also tell us what is Supabase and what do you have for us in terms of AI features in Supabase?
Oh yeah, thanks for the introduction, Majid. I'm so excited to be here today. Yeah, again, my name is Tyler and I am a developer relations engineer at Supabase. And just to go over what Supabase is basically a Postgres developer platform. What that means is when you're working on an application, you need some backend and you need some database to store the user-generated data. You also probably need some authentication, and you might need some storage to store user-generated files such as images or videos, PDFs, whatever it is. So basically, Supabase is a combination of these centered around Postgres database. So we strongly believe in Postgres database. It's a powerful database with a lot of features, well battle tested. A lot of huge companies use it for their main databases. And we want to basically make we want to make Postgres very accessible to you as a developer. Sorry, should I go into the AI stuff as well? And lately, Supabase has been working hard adding more AI features into its tech stack. Supabase has a vector database support, which we will look into more later on. But what it is it basically powers a bunch of AI applications on top of Postgres extension built by the community. So AI obviously can do a lot of things. AI can generate images. These days, it can even generate videos. It can talk to you. It can chat to people. It does a lot of stuff. But sometimes what AI struggles with is lack of knowledge. Like, for example, OpenAI's model GPT models are trained, I believe, until like the past, trained on data that are at least 3 years old or something like that. So it does not have the context of more recent news or events and stuff like that. So what this vector database allows us to find relevant content and feed it into AI so that it can basically understand. We can add some knowledge to the AI so that it can better assist your customers or better assist, your day-to-day workflow or something like that. So it has a lot of potential. It has a lot of modern applications, and we are excited to take a look at what it's capable of in this demonstration that I'll be showing you later.
That's interesting. So for those who have not yet started doing anything with Supabase, so I will put the link in the description below. Also, you may probably see it right now on top of this video. So you can click and watch our previous video with Taylor, which he actually showed us how we can use Supabase with Flutter. And we had like these pair programming together already. However, for this session, you've been talking about AI right now, Taylor. And so you said what you are doing with AI, the vector, things that you mentioned, integrating like all the ML models probably that we can do with this, vector database. I really like you to, if you can just start demonstrating like a project, like somehow how we can leverage this functionality, that would be very awesome. So for those who doesn't know really about vector database or the PostgreSQL vector database, functionality, how does it work? And even different AI models. I really like to know like what kind of different AI model that you are supporting. Are you supporting OpenAI, LangChain, or is it different? Would you go ahead and share your screen and maybe start showing us some code and maybe even building something together? We will get to that, right?
Yeah, for sure. Okay, let me, without going into too much details about the technical stuff behind it, let me showcase what's possible with this vector database. So right now on the screen, I have a iPhone app running on my iPhone emulator. And what this application is, it's just a simple list of movies that I found from a random API online. So as I scroll through, I see different kinds of movies, right? Think of this as like a Netflix type of application. Typically, after you watch a movie, those Netflix streaming services will recommend you a different movie for you to watch, right? How do they come up with that recommendation is what I want to demonstrate in this. So if I click a movie, for example, let me click Blue Beetle. This is like a hero type of movie with this good versus evil, and the superhero appears and basically knocks on the bad guys. So once I click into this details view, you see this you might also like section at the bottom of the page, right? And I have 6 movies right here. Some Doctor Strange movie, Man of Steel, Superman, all somewhat related to the actual movie that I have opened. And the way these set of movies are pulled in is powered by Supabase AI or vector databases. So the way it works is there's something called embeddings. Embeddings are a vector representation of some kind of data. It can be anything. It can be image data. It can be a whole bunch of text data, whatever it is. The point is we take that data and AI converts it to embeddings, a set of vector, and we store that vector in a vector database. And what vector database specializes in is that it can efficiently query that set of vector data. Now, you might be thinking, what good does a set of vector do? The whole point of this vectorizing or converting data into vector is that the AI takes a look at the data and it analyzes in a way data with similar context would be pointing to a similar direction. And then at the end, you query other data that have the similar direction to the main vector that you want to query with. So let's take a look at this a little more. So if I click into this Superman movie, I might also see a whole bunch of other hero movies, or maybe a bit of a children's movie. And then I can click into more movies and it'll show you more relevant movies, Kung Fu Panda. And then if I click into it, obviously a bunch of kids show, Wonder Woman, 1984. You can see that all these lists of movies are somewhat related to it. And the way I have it set up in this particular example is I took this movie description. I took every movie description in the database, converted them all into vectors, and then I'm searching against that particular description. And if you look at this particular example, Wonder Woman 1984, the description isn't that long, right? It can be longer. Some of these more recent AI models are capable of handling longer text. And what's awesome is even with this short paragraph that we have, it's still able to bring in relevant information and display relevant movies to us. So this is kind of one of the use case that you can easily get started with AI and add it into our application. We call this semantic search. So rather than doing like a keyword search, AI is able to look at the semantic meaning of the context or the data, and it's able to pull in information that are semantically related to the query data that you're searching with.
Oh, that's very interesting. Maybe I should pause and
Sure.
Stop you and ask one question here.
Mhm.
So, in summary, you take this description and you send it to your engine, and you will get like some response back, right? So, I have now a question here: is like every time you come to this page, will you might also like these 6 videos or movies are going to be changed, or is it going to be like the same? Is it like some sort of cache, or is it like always a refreshed or fresh query, let's say? How does that work?
Yeah, so for this particular example, nothing's cached, but the sample data that I have is static, meaning that I'm not like every day adding new movies as new movies come into the world. But if you were to add all the new movies that are coming out every single day or every single year, then the search result would be different. Like some of those new movies might be more similar to this particular movie. If that's the situation, then that particular new movie might appear as the first recommendation or something like that. Does that make
I
sense? Yeah.
Oh, yeah, absolutely. Absolutely. Okay, sounds great. Let's
Yeah.
move on.
Okay, yeah. So let me go into a bit of detail about how this particular example works.
Yep.
So the way it works is it's a simple Flutter application, and I have a details page. And in this details page, I'm calling a Supabase database function. So this is where all the magic happens. We are calling a Supabase database function called getRelatedFilm. What this database function does in the background is it's taking the target vector. So in this particular example, it's taking the Wonder vector from Wonder Woman 1984 and passing it to this particular database function. And all this database function does is just a simple create. It looks at this particular vector from that movie, it looks at all the other vectors, and finds the list of 6 top movies that have similar direction. And embeddings, in this particular example, I'm using OpenAI's embeddings API. But OpenAI is not the only AI companies these days that are providing embeddings API. In fact, pretty much all the AI players in the market have some kind of embeddings API. So Gemini has one, Meta for sure has one. And at Supabase, we recently introduced our own kind of embeddings, generating embeddings tool, if you will, powered by open source. So what I'm showing you on the screen right now is the latest addition to our AI feature set. And what it is within Supabase Edge functions. Before that, let me go into what exactly Supabase Edge functions is. So earlier I went into how Supabase is a collection of features like authentication, storage, databases to get you started with developing apps, right? And sometimes that's not enough, and you might need some backend code that you want to run for communicating to external APIs, or in this case, generating embeddings. So it's powered by Dino. So you will be writing Dino functions, which is a lot of fun. And what this feature allows you to do is we added this AI model into the Dino runtime, our own Edge runtime. So you are able to now generate embeddings without any external libraries or without making API requests, which makes it really fast to generate embeddings, which it makes it very efficient to generate embeddings. So within your Dino function, you can just call new supabase.ai.session, and then you give it the model. GT small is Olama model available to generate embeddings. And then simply you pass in the strings that you want to generate embeddings from, and then it'll output a set of vectors that you can just take and store into your Supabase database and then do awesome AI stuff with it. So let's see, where should I go from here?
All right, that's interesting, Taylor. So there are then a couple of functionalities that working together and to make these AI feature works, as I understood right now. Then it's gonna be edge functions. It's gonna be like the PostgreSQL database vector, functionalities. Do you have an example? I mean, you showed the example of in the Flutter part of it. When you say so in that example, when you mentioned this is a function, can you just show us that function and that we can take a look and see how it looks like,
For sure.
Is it the same edge function that you are saying, or is it a different type of function that you are saying?
Yeah, so it is the same type of function, but it's basically a Supabase edge function. So it's a Dino function. And
Okay.
it's actually surprisingly very simple. So here's what this function looks like. The first part is, okay, so okay, let's start from the top. I have some models defined. The first chunk is just setting up environment variables and whatnot for, API keys for OpenAI and Movies API.
Makes sense.
Yep. And then here I'm getting the list of movies basically, which I will casually skip because it's not the main, where the main magic happens. But once we get the list of movies from the Movies API, we are calling right here, we are calling the OpenAI API's embeddings endpoint. We are making a post request to this embeddings API, and we are passing the movies overview. So that was the description that you saw earlier. And just with this simple API call, we get a response back, and the response contains an embedding, which is just a vector, or it's really just an array of floating values. And if you're thinking, when you hear vector, you think of like two-dimensional vector or three-dimensional vectors, right? OpenAI, this particular model returns 1,536 dimension vector. So it's just a 1,536 length of array of floating values, which is kind of insane. It's hard to wrap your head around. That's a lot of dimensions. But yeah, at the end of the day, it's just a simple math to find out difference in angle between two vectors. So the number of dimensions is fine. The technology can handle it. At the end, you get an embedding, and then you're just storing it in a Supabase database. So here I'm performing a upsert. Upsert is just update or insert, and I'm just basically inserting that into the list of movies, and that's it. So this is where the preparation happens. We got all the movies data, and then we are generating embeddings from them, and then we store them in a Supabase database. Now, when
So you're actually adding that to PostgreSQL vector, feature that you mentioned, right? So after you get that, embedding, so you actually insert the data into the database right now.
Yeah, exactly. And maybe I should have started from that. So this is what the table looks like with SQL. Right here, we are creating a films table, and films table contains an ID, sure, title, makes sense, overview, that's the description that we saw earlier, release date, backshot path, these are just some metadata, and then embedding. So as you can see, this embedding column has a vector type, and then we are specifying the dimensions of the vector, 1,536. This is what this OpenAI's embeddings API uses. So this is what the table looks like, and this is all the data that we are inserting into from the Dino edge functions.
Makes sense.
Yeah, and then this is what the database function looks like that I was referring to earlier. So this is where the querying happens dynamically. So as you click on a movie, it lists 6 recommending movies, right? And this function takes an embedding of vector of 1,536 dimensions. So this is the target vector that we want to search against. And then it also takes the film ID, so which the ID of the film that the user actually clicked on, so that we can not return that from the response. And then the function's very simple. It's pretty much just a simple select statement. We want to select all from the films table, and then we want to make sure that the ID does not equal the film ID. So we don't want to, obviously the vector is going to be a perfect match if it's searching against its own. So we obviously want to not return that. And then order by, this is where the magic happens. This special symbol is used to basically order the list of data from more similar to not so similar. So the similar ones will come at the top, and then we are just limiting it to the first 6 records to be returned. So just with a simple SQL statement, we are able to query all the movie database and retrieve all the relevant data, and then return it to our Flutter application, which displays the recommended movie nicely.
That's very interesting. I'm by all means, I'm not an expert in database and especially vector databases, but maybe my question would be very silly or beginner, let's say, kind of question. What if this table, or you're now getting all the details from films table, and how is the performance of this statement at the moment? So I'm actually very kind of curious right now to understand, like, what if I have 1 million films in this table, like a records?
Yeah,
that still work pretty fast?
Oh yeah, that is a fair assessment. And yes, so Supabase Vector uses a Postgres extension called PG Vector behind the scenes. And PG Vector is an open source project. And the PG Vector has come a long way since its launch. And then especially the past few years since this AI hype all started. So whenever you talk about performance in database, we talk about indexes, right? And
Absolutely.
there is a special kind of index that makes this querying very performant. So that's the index that you see up here. We are creating a HNSW index up here. And I'm not exactly an expert in this field either, but what this does is clusters different vectors within the vector space. So it takes a whole bunch of data that might be somewhat similar, right? It chunks them into different areas within the vector space. And then when you actually query against a single vector, you don't have to look at every single one of them to find out which is more similar. You just have to look at a few clusters that are around that target vectors, and then you're able to, sort out which particular ones are actually similar to this querying vector. So there's ways to make it very efficient. And here at Supabase, we have many customers that are running AI applications, and they have millions and millions of records, and they are running it without any problems. So I can assure you that, Majid, if you want to chuck in a million list of movies, we'll be able to handle it just fine.
That's very interesting. I mean, it's so interesting that PostgreSQL itself have all of these feature, and you by leveraging those in open source. And I'm just looking at this statement right now and see like how simple it is to just get a related, movies. What I say, like it wasn't that easy a couple of years
It's
ago.
hard,
So
right?
a lot of algorithms were involved.
Yeah,
So
it's hard. I feel like it comes up a lot. Like, people say it's nice to have recommendation system, and then you might think about, okay, maybe we can do something with tags or, whatnot. But like, even with tags, it's kind of hard to, okay, so like, how exactly are you gonna query,
it was I
right?
just
It's
remember it was
hard.
like so many lines of code and logics and
Yeah,
algorithm just to come up with a good suggestion or personalized, suggestion. But now I
exactly.
take a look at this and say, all right, it's just a few lines of code and
Yeah.
it's mainly on the database file, and you get some embeddings from AI and you add it to the database, and voila, then you have a whole a lot of things that you can do with that. So this is just great. Okay, that's amazing.
It's very
I'm
amazing.
actually very impressed by this right now.
Thank you. Yeah.
So, in fact, then if you want to summarize right now, Taylor,
Mhm.
let's get our head around it, right? So, if I want to go ahead and do the same functionality, so the first thing I need to do, I need to start initializing some functions, edge functions, and also I need to create my tables or having my, PostgreSQL setup, let's say for this purpose, or
Mhm.
PostgreSQL's vector database setup, let's
Mhm.
say. Once I have these two, then I have some kind of data. In your example, it was a movie. So I just send whatever prompt I want to get answer from to an AI, model, whatever, wherever it is, Gemini or OpenAI or whatever.
Exactly.
And then I get some embeddings, which are technically vectors.
Yep.
And then we will add these vectors to the database. And then this database, PostgreSQL, we can define a function which is helping us to running some statements, SQL statements in this case.
Yep.
And then that function is going to return a list of things based on those vectors. So in this case, you are actually comparing, you're ordering like based on the vectors, but I may have different logics. That's not important.
Mhm.
But then this is how it works. And then at the end, in my client app, which in this case, let's say it's my Flutter application,
Mhm.
the only thing I need to do is I need to just say, hey, function, whatever, get movie, related movie or whatever,
Oh, yeah.
just give me the movies, right?
Exactly.
And then I get the movies.
Yep.
That's just as simple as that, right?
Yeah. Exactly, exactly. All you're doing is you're just calling this Postgres function that we saw earlier, and it just returns the related movies or related data or whatever you have. I think it has a lot of applications. E-commerce, you can use this for sure. I think it'll be great. Yeah, there's so many applications that you could apply it on.
That is interesting. So this was the feature about AI that we've seen. So
Mhm.
is there anything else in this space, in this area that now you have it in Supabase and you want to show us?
Yeah, there is. I guess there's a little bit of more use case when it comes to this similarity search. So this particular demonstration was the simplest form, if you will. It just has, we have a whole bunch of vector data, and we are throwing a vector data at the database, and it returns a few records that are similar to that data, right? But we can actually take this beyond that. And this is where I talked about earlier how OpenAI, for example, it's ChatGPT ChatGPT's data is only trained up until like 2021 or something like that. So it doesn't have the more recent information regarding, if we want to ask something awesome about like Flutter macros these days, right? That's the hot topic. ChatGPT obviously does not know what Flutter macros or dot macros are. So how do we overcome this challenge is the next thing that I want to talk about. So there's a type of application called RAG application. It stands for Retrieval Augment Generated Generation. What it means is before asking the AI the question, we take some relevant data, we pass those information to the AI saying, hey, here's a question, but before you answer this, here's some materials for you to look at that might contain the answer to this question. And then the AI can read those materials on the spot. For example, it can learn about Dart macros, and then it can return a more relevant response to the user. So that's what a RAG application is. And the key point of this RAG application is being able to find relevant information quickly so that we can feed it into AI. And if you know how to, find relevant information, similar information, well, you just saw it. That was all the vector database stuff that we saw earlier. So we can create a smart chatbot. Here's what we have at Supabase actually. If you go to supabase.supabase.com, we have a chatbot that we can bring up by hitting Command K. And we have this Ask Supabase AI feature. And here we can ask any kind of Supabase related question, even if it's one of the newer features. For example, how do I generate embeddings using Supabase Edge functions? I haven't actually tried this prompt, so let's see if it actually brings up a nice set of information. If not, we can look at something else. But okay, wow. So it is actually bringing up all the relevant information. So Supabase Edge functions supports this Supabase.ai syntax and uses GT small model. And here's some code samples. The way this works is obviously, this is powered by ChatGPT, by the way, but obviously ChatGPT does not have context of this more recent use. What it does in the background is we have generated embeddings of all the documentation, internal documentation of Supabase, and then we have that stored in our database. And then when we ask this question to the Supabase AI, we are quickly querying that database of embeddings of Supabase documentation, finding relevant information, and then take that relevant information and add it to the prompt to ChatGPT saying, hey, here's some information about Supabase AI on its functions. Here's a question that user asked. Would you be able to answer this question given these information? And it works out pretty nicely. So yeah, being able to retrieve similar information quickly is a key feature to creating nice AI applications like this.
That's interesting. Is this something that Supabase user can start doing or using?
Yeah, oh yeah, for sure. We have what we call a headless starter kit. So it's the same thing. We took that and we stripped away all the Supabase specific stuff. And what it is you can chuck in a bunch of markdown files, and then it'll generate embeddings from OpenAI model, store in Supabase database, and then you can query them in a similar fashion.
That's interesting. So technically, I can create my own like chatbot as you have if I use Supabase, as simple as just a few lines of code, maybe, or just a few clicks, and then I get this.
Exactly.
But that's impressive.
Yeah.
That's good. That's all right. I mean, so many good features. We need to get our hands onto code and just write some stuff and see how it works, actually. But I think, do you have any more things that you want to share maybe about this AI stuff?
I think I've talked about all the stuff that I wanted to cover today. Thank you.
Okay, that's fantastic. So I guess, I mean, this was interesting. The two features that you showed or you talked about it, and especially the previous one, the amount of code that I've seen in the PostgreSQL and in Supabase, how fast you can have such a feature. This is fantastic. Taylor, thank you very much for joining me today and sharing the latest AI innovations at Supabase and what we can do right now with Supabase and our client application. I guess Supabase is supporting actually many frameworks and client application out of the box. And I mean, it can be a good backend as a service for many front-end application. If you have it in mind to build such any project or migrating to any backend as a service, consider Supabase. And you can always reach out to Taylor. He's on social media, which I will show his Twitter account and or X and other social media in the description. And also you will probably see it right now here under this video, and also Supabase website. So for the last part, usually we have this last part of this session, Taylor, that you have a chance thing you want to share with us.
Oh boy.
Go ahead and tell us.
Yeah, okay. So the best way to getting started with Supabase is going to database.new. This will actually take you to a page that you can just create your Supabase project. So just remember this, database.new. It's simple as that. Type that into your browser, create your Supabase project, and have fun.
Okay, I even didn't know this one though. This is new. So that's good. Database.new. I'll put it in the description below and have fun. Thank you very much, Taylor. Have a good day.
Thank you for having me.
Thank you for watching. See you next time.
Bye-bye.